Today we're going to be going through the notes for 9-3, solving two-step inequalities. So this topic has to do with, first off, solving two-step inequalities, but also with setting up inequalities that represent certain situations. So when we're looking at different inequalities and figuring out if I'm going to have a greater than, less than sign, or if I'm adding or subtracting, I need to look for keywords in the sentence. So our first sentence reads, 9 plus 5.5 times a number is more than 50. So I can actually write that directly as an inequality. I see 9 plus, so I know that's 9 plus 5.5 times a number. We don't know what that number is, so that's where we're using a variable. And since in all these cases we're using n, I'm going to use n here. So I have 5.5 n is more than 50. Now notice that those words is more than, that tells me that I'm going to use my greater than inequality, so it's greater than 50. So my inequality that works for this situation would actually be my very first inequality here. 9 plus 5.5n is greater than 50 because 5.5 is the same as 5.5. Now the second one, we're going to have to look at the situation and keep in mind with two-step inequalities, just like equations, a lot of times they give us a total. So it says a lunch special costs $9. So we know our lunch special costs $9. The Egyptology Club can spend at most $50. How many lunch specials can they order if they also share a dessert that costs $5.50? So we do see that there's a total, and we see right before the total that there are the words, they can spend at most $50. So I know that that total is going to go by itself on one side of the inequality, and at most means less than or equal to, because it can be smaller than 50, or they could spend $50. So it has to be, their total has to be less than or equal to 50. Now what makes up their total? So we see that the lunch special costs $9, and then they're going to share dessert that costs $5.50. So $9 is how much they're going to pay per person, and then $5.50 on top of that. So for that reason, I'm going to put 9 in because I have to take 9 times the number of people, or times the number of specials ordered, and then $5.50 is not multiplied by the number of specials because it's just something extra that they're buying. So 9n plus $5.50 is less than or equal to 50. So I know that my third inequality here represents the second situation. Now I can see already that the second one probably is going to represent the last one, but let's think about this. So it says you read a 50-page chapter about the early Egyptians at the rate of 5.5 pages per minute. After how many minutes will you have fewer than 9 pages left? Now notice that we see our inequality word right there. You have fewer than 9 pages left. So even though in this case I would say that we do have a total, and normally we would set up our inequality a little bit different, or our equation a little bit differently, since this is an inequality, we have to put that 9 by itself, because notice it says fewer than 9 pages left. So that means that the number of pages has to be less than 9. So on one side of the inequality, I'm going to have less than 9. Now you can see that I started out with 50, and then every minute I read 5.5. So there was 5.5 less that I still had to read. So I start out with 50, and I'm taking away 5.5 for every minute. So minus 5.5n. Now in this case they wrote 5.5n, but we can see that that second inequality would go for this third situation. 50 pages minus 5.5 for every minute, it has to be less than 9. So we're trying to find the number of minutes. Okay, so mostly what we're going to be looking at today, so we will look a little bit more at setting up inequalities, but we're also going to look at how we solve two-step inequalities. Now here is the nice part about solving inequalities. Just like we talked about before, it is pretty much the same thing as an equation, the way that we solve it. The only difference is that if we multiply or divide both sides by a negative, we have to flip the sign. So what they're explaining up here in our key concept is just that as we solve it similarly to an equation where we make the inequality simpler and simpler as we go along until we know what x is greater than or equal to or less than or so on. So our first inequality that we're looking at is x over negative 3 plus 12 is less than or equal, or is less than, 28.9. So the first thing that we have to do here, think of this just like an inequality. First thing is that we have to take away 12 from both sides. Now they show it in the same line, but that's the same thing as how we show it by subtracting 12 from both sides. Now when they do that, they have x over negative 3 is less than 16.9. Now we know that to undo division, we have to multiply. So if I have x divided by negative 3 is less than 16.9, to get rid of that, I have to multiply both sides by negative 3. And that cancels out the negative 3 on the left side to leave us with x. And then on the right side, we get negative 50.7. Now notice the important thing that we see here though. Because we're multiplying both sides by a negative, we have to flip our inequality sign. So before it was less than, and now our sign is going to be greater than. So we have x is greater than negative 50.7. Now just like we've been talking about the past couple of days, we first solve, second we graph, and then third we check. We check our answers. So far they have solved it, and now we're ready to graph. Now I see that I have a greater than sign, which means that I'm going to have an open circle on negative 50.7, and notice that it says x is greater than negative 50.7. The values that are bigger than negative 50.7 are to the right. So we draw an open circle on negative 50.7 pointing to the right. Now we have two ways that we have to check our answer. Remember that the first thing that we have to check is we have to check the circle. And that's what they're showing us at the bottom. So we want to make sure that the circle was placed in the correct spot. And so we have to replace x with negative 50.7 and then solve to make sure both sides are equal. When I do that, negative 50.7 divided by negative 3 gives me 16.9, and then 16.9 plus 12 does give us 28.9, so we know we got the right answer. If both sides were not equal, that would show you that you made a mistake when solving your inequality. Now, that's the first thing that we have to check, but we also want to make sure that our arrow is facing the correct direction. So I just have to choose one value that's greater than negative 50.7 to make sure that my inequality is correct. So that's what they're doing right here. So they decide to plug in 0, and we see on the front side that 0 was a possible solution. So whenever you can choose 0, it's a good choice for checking your work. So they replace x with 0, and then in this case they use a less than sign. That's what we started with, because they want to make sure that when I plug this in, that what I get truly is going to be less than 28.9. So when we replace x with 0, first we take 0 divided by negative 3, which just gives us 0, and then 0 plus 12 gives us 12. 12 is less than 28.9, so we know that our arrow is facing the correct direction. So always make sure that you check first your circle, so plug in the actual value that you got in your inequality, and then second, check your arrow, check your line. Make sure that one of the values that makes the solution true does work for your inequality. Now we're going to look at one word problem that's an inequality problem, and we're going to pick out our important information and then solve it. So it says a magician's assistant makes $10.60 an hour. If he has already saved $53.70, how many hours must he work in order to save at least $165? So let's underline our important information. So he makes $10.60 an hour. So every hour he makes $10.60. He already has saved $53.70, and it says how many hours must he work? So we're trying to find how many hours must he work in order to save at least 165. And if you see that keyword at least, that right there tells us that 165 is going to go by itself because that's next to our words for an inequality, at least. Now to start off with, we always want to define our variable. So in this case, since we're finding the number of hours, I'm going to call h my hours. And then in this case, we do have a total. We have a total amount of money, and it's next to our inequality words. And so we're going to have 165 by itself. And notice that it says at least 165. So that means it could be 165. It could be more than that. And so that means that that amount that he's making has to be greater than or equal to 165. Now notice what makes up that 165. We have the 1060 an hour and then the 5370 that he already saved. So this 5370 isn't going to be multiplied by the number of hours because it's a flat amount that he already has. 1060 does need to be multiplied by the h because it's 1060 for every hour he works. So our inequality is going to be 1060 h plus 5370 is greater than or equal to 165. So I'm going to start off by drawing a line down my inequality, and I have to start by taking away 5370 from both sides. So when I take away 5370, that is going to give me 111.3. I still have my greater than or equal to sign because I didn't multiply or divide by a negative. And then on the left side, I still have 10.6. 10.6h. Now last step is that I have to get h by itself. And because right now I'm multiplying, I can do that by dividing. So I divide both sides by 10.6. And that's going to give me the answer 10.5. So h has to be greater than or equal to 10.5. Notice that I didn't change my inequality sign because I wasn't dividing or multiplying by a negative. Okay? So we've done the part where we wrote our inequality, we've graphed our inequality, now we're ready, or sorry, we've solved our inequality, now we're ready to graph it. So when we graph our inequality, we're going to draw our line. I usually put my number somewhere towards the middle, so 10.5 somewhere towards the middle. I'm going to put 11, 11.5 on one side, 10, and then 9.5 on the other side. Because it's greater than or equal to, I'm going to put a closed circle on 10.5 because it can be 10.5, but it could be greater than or equal to, so anything bigger than 10.5 too. So that means my arrow is going to face to the right. Now to save us time, we are not going to check our work on this one, but if this were a homework question, you would need to check your circle and check your line to make sure they're correct, just like the example we saw before this. Now for the last set of examples, notice what they're asking us to do. They say 3 of the inequalities below have the same solution. Cross out the inequality that has a different solution. So we have to solve each of these 4 solutions separately. So let's start out with 2y plus 15 is greater than 6. And just like the last one, we're just going to solve. We're not going to worry about checking our work to save us some time. So I'm going to start off by drawing a line. I know that I undo addition first by subtracting. So I get 2y is greater than negative 9. And then to undo multiplication, I divide. So I divide both sides by 2. Now notice here that we were not dividing by a negative, so the sign did not flip. So I still have a greater than sign. So I get y is greater than negative 4.5 or 4.5. Either way is fine. All right, so the first one we got, y is greater than negative 4.5 or 4.5. So let's try our next one. So our next one we have 6.8y plus 27 is greater than negative 3.6. So I have to start off by taking away 27 from both sides. Now when I take that away, I get 6.8y on the left side, and I get negative 30.6 on the right side. Now again, notice I didn't multiply or divide by a negative, so my sign stays greater than. So now to get y by itself, notice I have 6.8 times y, so I have to get rid of that by dividing. When I divide by 6.8, that gives me y is greater than negative 4.5, or negative 4.5. So same thing as last time. Now keep in mind here that again I did not flip my sign because I did not divide by a negative. Okay, so now we're ready to move on to number 3. I have negative 1/3 y plus 27 is greater than 28.5. Now for this one, again, I draw a line through my equal sign, and I start off by taking away 27. Now if I take away 27 from 28 1/2, that works out pretty nice.